Good afternoon, dear students. On our previous lesson, we were working with elementary geometry figures like points, points, planes, and straight lines in the space. And today, our topic is the second order curves, such as ellipse, parabola, hyperbola, and the circle. So uh, just let me remind you some information about the second order curves. So this is the general equation of the second order curve. Basically, it's a quadratic form in the general in the general form which depends on two variables. This is the canonical equation of the circle, where A and B are coordinates of the center, and R is radius. You know it from the school. Then canonical equation of the ellipse. So where A and B are semi-axis of the ellipse. So A is the semi-axis on axis X, B semi-axis on Y. Fauci of the ellipse coordinates can be found with the following formula, then eccentricity and directrices. By the way, here is the ellipse is centered in the beginning of coordinates. If the center is on another place, so we do like the same with the circle. So in power of 2 there are, so we subtract coordinates of the center. With what about hyperbola? So we can see that sign here is changed from plus to minus, so be attentive with that, it's important. As well, we can calculate Fauci for it, but so Fauci coordinates, and as well, be careful that for ellipse we have minus in square, so minus in square root and plus for hyperbola. So the eccentricity, so for ellipse is it is from 0 to 1, not including 1, excluding. And for the circle, it's always 0. By the way, circle is the partial case of the ellipse. When semi-axis, so if we so when the semi-axes are the same and just equal the radius, then yeah, eccentricity of hyperbola is always greater than 1, so it can be so of course it's finite. Yeah, the formula is for directrices is the same, and also it has asymptotes. So straight lines, you know that graphic, so graph of the function of the curve doesn't uh, intersect with them, but like прямую. So it is going very near to it. So parabola equation, canonical equation, it's like our quadratic function. Here is y, but we can slope these variables, and it will have and it will be oriented with the different axes. So focus is coordinates are the following. So parameter p by 2 and 0. Eccentricity for parabola is always 1, and it has only one directrix. X equals minus b by 2. Any questions for now about the theory?
No.
No questions as expected, so let's start practice. So what do we have to do? First of all, we need to write down canonical equation of the ellipse. If so, in the first case, distance between Fauci, incorrect. So equals 24, and eccentricity equals 3 by 4. So what do we have? So distance between foci equals 2c. So uh, 2c equals 24. And it means that c equals uh, 20. Oh, 12. Yeah. Then eccentricity. So eccentricity equals 3 by 4. And it equals c by a. Yeah, if I'm not mistaken, by the way, let me check. Yeah, so c by a always. So we can find a from here. So a equals c by epsilon. So 12 by 3 by 4. So, okay, 12 by 4 by 3. So so it equals 16. A equals 16. And a in power of 2 equals 256. So then we need to find B semi-axis. So C, so we remember that for ellipse, it is the same. So A square minus B square. So square of B equals square of A minus square of C. So it equals 256 minus 144. So it equals 112. Okay, let me check. So yeah, correct. So the equation is the following. So x in power of 2 by 256 plus y in power of 2 by 112 equals 1. And we also can extract square roots, so we write it like in power of 2, but of course if we need. So it basically means when so where it intersects axis, coordinate axis. Then the next section, so A is complete. What next do we have to find? Length of the semi-minor axis equals 5, and the eccentricity equals 12 by 30. So let B is the same, so the semi-minor axis, so the small axis. And the eccentricity equals 12 by 13. So how can we find B from the, oh, we need to find A because we have already B. So eccentricity equals C by A. Then, so it equals, so for C, so A in power of 2 minus B in power of 2, so substituting this expression, so by A. And then we need to solve this equation with respect to epsilon, to A. So what do we have? But even not A, but A in power of 2. So I multiply by A and also raised to the power of 2. So A epsilon in power of 2 equals A in power of 2 minus B in power of 2. So according to it, so A by epsilon minus 1 equals minus b in power of 2. So a in power of 2 equals b in power of 2 by 1 minus epsilon. Epsilon in power of 2, by the way. And what does it equal? So 25 by 1 minus 144 by 169. And let me not calculate everything. Yeah, so it equals 169. So the equation of the ellipse is the following: x by 169, x in power of 2 plus y in power of 2 by 25 equals 1. So found everything. Then, so this part is solved. Then part C. So we know that ellipse passes through points 3.30 and 2 square root of 5 by 3. How to solve? Any ideas? Suggestions? What could you suggest how to solve?
We'll just show formula of ellipse.
Yes, of course, I will show you formulas. So what we basically need to find?
The center.
Uh, so so the center is in the beginning of coordinates. So we need to find A and B. How to
Radius.
find?
From vector. Line.
So what find? Sorry.
A vector magnitude.
No, which vector magnitude?
From the center to the points.
So you mean a semi-axis, right? So A and B.
Yes.
Yeah,
Yes.
correct. And how to find them?
We have edge of our ellipse, so we can find AB vector and divide it by 2, and it will be AB.
Well, I got your idea, but yeah, I understood. But we have the simple solution. So we need to solve the system of equations relative A in power of 2 and B in power of 2. So now what do we have to do? So we substitute the coordinates of the first point and coordinates of the second point into the canonical equation. Uh, so 15, oh, no, 5 by 9 here, and it equals 1. So we need to solve equations with respect to A in power of 2 and B in power of 2. So from this equation, the first equation, we know that A in power of 2 equals 9. So uh, let's find B in power of 2. So 6, that's mistake, not, so 2 in power of 2, so 4. 4 by 9 plus 5 by 9, I won't uh, modify it for now. So equals 1. So 5 by 9 by b in power of 2 equals, it equals 5 by 9. So b in power of 2 equals 1. So the equation of the ellipse is the following. X in power of 2 by 9 plus y in power of 2 by 1 equals 1. And this is the equation of the ellipse. So, any questions about this task? A, B, C parts?
No.
Okay, no questions. So we need to, the next, moving to the next exercise. So we need to find eccentricity and equation of asymptotes for hyperbola. And the question how to solve it. So what do we have to start with? To find eccentricity and
We need to
asymptotes.
substitute this equation to the canonical form.
Yeah, we need to transform to the canonical form, correct. So we divide both parts by 144. And finally, if we reduce everything, so x in power of 2 by 16 minus y in power of 2 by 9 equals 1. So a equals 4 and b equals 9. Oh, not 9, but 3. So we need to find eccentricity. So first of all, we need to find the coordinates of the Fauci. So C equals, so in the case of hyperbola, A in power of 2 plus B in power of 2. By the way, like hypotenuse. So and it basically equals 5, so good numbers. So eccentricity equals C divided by A. It equals 5 by 4. And it equals, so it is greater than 1, so this value is valid. And now we need to find asymptotes. So asymptotes are found with this formula. So the first asymptote equals, so b by a, so 3 by 4x, and the second asymptote minus 3 by 4x. Any questions about this task? Okay, if no questions, we will move next. So the next task is to find, to write down equations of hyperbola. So when we have such the following condition. So for part A, so we need to find A and B. How to solve, how to find them. Basically, that's spoiler for you. I am opening formulas for you. Okay, no ideas. So with these formulas, we need to so we need to find A and B. So C equals 10. So what do we have? A in power of 2. So square root is over A in power of 2 plus B in power of 2 equals 10. So the first equation. And the second equation, A, no, not A by B, but B by A equals 4 by 3. So we have two equations for two variables, so everything what we need. So let's express B. So B equals 4 by 3A, and so A in power of 2 plus 16 by 9 in power of 16 by 9 A in power of 2. So square root of this sum equals 10. And now let's find A from this equation. So let we raise it to the power of 2. So 20, and also we will add everything. So 25 by 9 A in power of 2 equals 100. So A in power of 2 equals 100 by 9 divided by 25. So it equals 36. So A equals 6. And B equals, so 4 by 3 by 6. So it equals 8. And now we can write down the canonical equation. So it is the following. X in power of 2 by 36 minus y in power of 2 by 64. And it equals 1. So found the canonical equation. Then the second case, so hyperbola passes through the point A minus 7, 0, and eccentricity equals 8 by 7. So the same. We need to find the system. So we need to find everything that we need. So the first equation where we can find A, so 49 by A in power of 2 plus 0 by B, minus 0 by B in power of 2 equals 1. So where we can find that A equals 7. So found it. Then the eccentricity. So eccentricity equals C by A, and it equals A in power of 2, so square root of A in power of 2 plus B in power of 2 divided by A. So now we can find B from here. So let's do the following. So I multiply by A and raise to power of 2. So B in power of 2 equals epsilon. Okay, 1 minus epsilon in power of 2 by A in power of 2. So 1, sorry, no, epsilon minus 1. My bad. So confused the sign, and nobody told me about it, that something went wrong. So epsilon in power of 2 minus 1. So 1 by 7, 1 by 49. No. Not correct. Let me recalculate. So 40, so 64 by 49 minus 1 by 49. So it equals 64 minus 49 equals 15. Oh, 15. Yeah, and b respectively equals square root of 15. So A found, B found. So we can write down the canonical equation of the hyperbola. So x by 49 plus y by 15, y in power of 2 by 15, not plus, but minus. You also will always have to be attentive with the signs. So minus y by 15 equals 1. And this is the final answer. Of course, we can write here 7 in power of 2, square root of 15 in power of 2. It depends on tasks which you need to complete. Basically, that's enough. Any questions about this task?
No.
No questions. Okay, let's move next to the task number 4. So we need to find to write down equations of parabola. So let me open formulas for you. So part A is the following. So it is symmetric relative to OX. So it means that parabola looks like this. So yeah, and it passes through the start of coordinates. So we need to find the parameter. So we substitute this point into the equation, and we will find the parameter p. So 9 equals 2p by 2. So p equals 9 by 4. So then the canonical equation is the following. Y in power of 2 equals 2 by 4x, 2 by 9x. And this is the answer. So parabola is quite simple in this way, in this meaning. Well, the next. So B, we need also to find the parameter p. But here attentive. So the directrix is the following: y equals 1 by 2. So it means that the parabola is the following. So like this. I don't. Oh yeah. So it passes through the beginning of coordinates, but so its location is the following. So we just swap y and x places. So minus p by 2. So in our case, we just swap x with y. Minus p by 2 equals 1 in power of 2. Oh, 1 by 2. So it means that p equals minus 1. Then x in power of 2 equals minus 2y. And that's it. So the canonical equation of the parabola. Then analogically, so directrix equals x, so equals -2. X equals -2. So minus p by 2 equals -2. So it means that p equals 4. So y in power of 2 equals 8x. And that's it. Any questions about this task? About parabola equations?
Can you scroll down?
Yes, sure. Or maybe upper.
Can you explain once again how we find P in the first P?
You mean A point, right?
P were 9/4.
Okay. So we know that the parabola passes through these points 0, 0 and 2, 3. So to find, so we need to find P. How to do it? So analogically, as we were finding A and B semi-axis for ellipse or hyperbola, but for parabola, we need to only find the P parameter. So if we substitute coordinates of point A into the equation, so 3 here instead of y and 2 instead of x. So we just received the linear equation relative to parameter p, to the variable p, and then we find its value, and that's it.
Okay, understand.
And point 0, 0 just to understand for the understanding how this parabola is located. So, okay, no questions. So more questions about this task?
In general, always understandable.
Generally understandable. Okay. That's great. So now moving to the next task. Task number 5. So now we need to find equations of the circle. We move it to the top. Not to annoy me. So for the part A, we need to find the equation of the circle if circle passes through vertices of hyperbola and has center in the point A, so with coordinates 0 and -2. So let's draw graphs. So hyperbola, and the circle. Okay, imagine. So just believe me that this is the circle, and so it crosses. So it passes through vertices, and this is the center. So for better understanding. So what do we need to find? We basically have. So we already have coordinates of the center. So the equation will be the following. So x in power of 2 plus y plus 2 in power of 2 equals r in power of 2. So we need to find the radius. And how to find the radius? So any ideas? No idea. Okay. So we need to find these vertices. So vertices of hyperbola, and then from vertices with knowing vertices we will find the radius. So first of all, let's transform the equation of the hyperbola to the canonical form. Okay. So 12x in power of 2 by 156 minus 13 y in power of 2 by 156 equals 1. So if I'm yeah, so basically 156 equals 12 by 13. So x in power of 2 by 13 minus y in power of 2 by 12 equals 1. So coordinates of the vertices are the following. So 0 and minus square root of 12 and 0. Oh, no. Incorrect order. So minus square root of 12, 0, and square root of 12, 0. So found coordinates. So we need to substitute them into this equation to receive the radius. So 13, not 12. Okay, so 13 plus mhm. So 0 is here plus 4 equals r in power of 2. So the radius in power of 2 equals 17. So finally, the equation of y. Yeah, here is mistake, so it will be equal 17. So the equation of the circle is the following. So x in power of 2 plus y plus 2 in power of 2 equals 17. So that's it. Then part B. So what do we need? We need to. So what we have? So it passes Cauchy of the ellipse and has the center is in the top point of the ellipse. As well, let's draw a little bit. Draw graphs. Just forgot about shapes that are useful for us. Okay. Okay. Nice. And then let's draw the circle. Mhm. So y, x. So we need to find, so write down the points that we need. So this is the center. It has coordinates 0 and b. We will find b just with the transforming equation of the ellipse to canonical form. And here we have points minus c 0 and c 0. So we need to find first of all b and c, and after that we will find radius. So b will be the one of coordinates. So first of all, yeah, reducing our so transforming ellipse. It could be simple, but nevertheless. So transform into the canonical form. So 3x in power of 2 by 12 plus 4y in power of 2 by 12 equals 1. So x in power of 2 by 4 plus y in power of 2 by 3 equals 1. Okay. So b equals square root of 3. So we found the center. So the equation will be the following. So x in power of 2 plus y minus square root of 3 in power of 2 equals r2. So we need to find only this value. So let's find Fauci. So let's find c, by the way. So how to find c? So remembering this formula, so a in power of 2 minus b in power of 2 and the square root from here. So what do we have? So square root of 16 minus 3 equals square root of 13. Okay. So yeah, that's not so. Stop. 4. Damn it. Yeah, so 4 here. So my bad. Yeah. So just it is already powerful. If so. So c equals 1. So let's substitute. So 1 plus. So y is yeah. So by the way, f 1 2 equal so has coordinates plus minus c 0. So 1 plus 3 equals r in power of 2. So radius in power of 2 equals 4. And let's write down the equation. So x in power of 2 plus y minus square root of 3 in power of 2 equals 4. This is the equation of the circle. Any questions for now?
Can you scroll up, please?
Okay. To the part A or B?
No, B.
Mhm.
And a bit down, please, again.
Mm-hmm.
Everything understandable.
Okay. More questions? Okay, if no questions, let's have a break and then we will continue define curves of the second order. So we will have to reduce to the canonical form and find in characteristics. And now let's have a break for 5 minutes. Okay, let's continue. So, I'm cleaning the board. So we need to find, so we need to define which curve corresponds the given equation. So, first of all, we need to reduce it to the canonical form with extracting perfect squares. So let's go. So first of all, let's group all of them. So 4. So I can so group x with x, and also I can divide it by 4. So for x in power of 2 minus 2x plus 9. So analogically, so y analogically to x. So y minus y in power of 2 minus 4y plus 4 equals 0. And now let's start extracting perfect squares. So x minus 2 minus 2x plus 1 and minus 1. So we will reduce it. Plus 9 by y in power of 2 minus 4y. Here is a mistake, nobody told me. Plus 4 minus 4 plus 4 equals 0. So 4 x x minus 1 in power of 2 minus 4. So I moved this minus 1 out of brackets. Plus 9 in power, so y minus 2 in y minus 2 in power of 2 and minus 36 plus 4 equals 0. Continuing. So let me copy and paste now some parts of it. So erasing this. This. So moving constants to the right part, and basically what we have. So we already can say that this is the ellipse in the center of so in the center in the point 1. So coordinates of the center 1 and 2. But let's find semi-axis. So x minus 1 in power of 2 by 9 plus y minus 2 in power of 2 by 4 equals 1. So a equals 3, b equals 4, or equals 2. So found. Now we need to find other characteristics, all characteristics. So let's find Fauci. So we know that the formula is the following. So so C equals A in power of 2 minus B in power of 2. So square root of 5. So the eccentricity is the following. So we divide C by A. So it equals square root of 5 by 3. And it basically less than 1. So the result is valid for the ellipse. And now we need to find Fauci coordinates, and here we need to be attentive that the center of the ellipse is not in the beginning of coordinates. So we need also to add coordinates of the center. So F1 has coordinates minus square root of 5 plus 1 and 2. So so we need to add the center coordinates. And F2 has coordinates square root of 5 plus 1 and 2. So found. Let me remember what we need to find else. Yeah, we need to find directrices. So D1. We also need to add coordinates of the center. So for directrix D1, x equals so epsilon by a. Yeah, by the way, plus minus epsilon by a plus xo. So means so plus 1, this coordinate of the center. Yeah, 1, 2. So directrix 1. So it equals so eccentricity by a. So square root of 5 by 9 minus square root of 5 by 9 plus 1 and not correct recording. So D1 is the following, so that x equals this, and D2 x equals square root of 5 by 9 plus 1. So we found all characteristics. Any questions
Why we
about ellipse? No questions, right? Okay,
Uh,
and now let's, yeah, we
can-
also need
can
to
I ask?
build a question, yeah?
Why we add 1.2 for focuses? To focuses?
Yeah, explain. We do it because the center is not in the beginning of coordinates. It is aligned in points 1 and 2. So as the center is moved, foci are moved as well. Have I answered your question?
Mm, so it's one number, yes? 1.2. Or it's це одне число, чи ми його окремо додаємо до мінус корінь з 5? Я цього не розумію.
Ми робимо паралельне перенесення фокусів на координати центра. Тобто до іксової координати фокуса, іксову координату центру, і до ігрекової координати фокуса, ігрекову координату центру.
Все, я зрозумів. Я думав, що це одна координата, і тому я...
No, two different coordinates. And now I will show you the graph of the ellipse. So with all points that required. So the center in the point 0, 0, 2. Then, by the way, vertices of the ellipse as well we have here. So we also add semi-axis to so we add center to the semi-axis, and then we receive coordinates of vertices. So foci f1 and foci of f1 f2. So 1 minus square root of 5, 2, and 2. Also 1 plus square root of 5, 2. So that this is this. Then directrices. So analogically, this and this. Yeah, and accidentally. So if I hide this graph, so this equation just so this is transformed to canonical form just to verify that everything is correct. Any questions about the graph? I will share the link with you. I hope that you will be able to open. Okay, now moving to the next curve. So curve B. So if no questions. So as well, doing the same. So x in power of 2 plus 2x minus 9 y in power of 2 minus 4y minus 44 equals 0. So let's do analogical stuff. So x in power of 2 plus 2x plus 1 minus 1 minus 9 y in power of 2 minus 4y plus 4 minus 4 minus 44 equals 0. So x plus 1 in power of 2 minus 1, then minus 9 y y minus 2 in power of 2 minus plus 36 plus 36 minus 44 equals 0. And now let me move three coefficient, so constants to the right side. So minus 8, minus 9, so 9 on the right side. And then, so writing down the equation. So as we can see, this is the ellipse. Oh, no, hyperbola. Hyperbola, of course. So x plus 1 in power of 2 by 9 minus y minus 2 in power of 2 by 1 equals 1. So this is the hyperbola in the center with, so coordinates of the center are the following: minus 1, 2. So A equals 3, B equals 1. Found. Then, so finding Fauci and eccentricity. So A in power of 2 plus B power of 2 and square root of this sum, so equals so 9 plus 1 square root of 10. Okay, so that's coordinate of C, and epsilon equals C by A, so it equals square root of 10 by 3, and it is greater than 1. So correct. Then, what else do we have to do? Yeah, so Fauci. F1, so adding, so minus 1 plus square root of 10. Oh, minus 1 minus square root of 10. And plus 2, yeah, and 2. And F2, so we add to point C0 coordinates of the center. So -1 plus square root of 10 and 2. So found. Now finding directrices. So analogically. So for directrix 1, so x equals square root over 10 by 9 minus 1. And so minus here. And d2,
But why by 9?
because we divide, so we need to divide eccentricity by a semi-axis.
But
So the
A
formula
is
of the directrices of hyperbola and ellipse as well, so the same. So we divide a by the eccentricity.
But our A is 3.
Yes, so eccentricity is the square root of 10 by 3, and we divide it by 3 as well. So we divide this value by 3. So and now we have square root of 10 by 9.
Yes, we understand. We multiply 3 by 3 and we got 9.
Yeah, so just arithmetics, yeah. So when studying advanced calculus, we are forgetting arithmetic, but that's not a good idea. Okay, so found directrices. And what else do we have? So characteristics of asymptotes. Characteristics of parabola asymptotes. And we need to do the following. As well, we need to take the center into consideration. So asymptotes are the following. Y minus YO equals plus minus B by A x minus XO. So we need to subtract coordinates of the center. So take it into the consideration. So the first asymptote, so y1 minus 2 equals so minus 1/3 plus 1. So y1 equals minus, so x plus 1/3. So y1 equals 5/3 x minus minus 5/3 3. Minus 5 by 3. So okay. No, 7/3. Yeah, I also forget the arithmetics. That's my problem as well. So then y2 minus 2 equals 1/3 x plus 1/3. So y2 equals so 7/3 x plus 7/3. If I don't confuse anything.
probably -1/3 were the first.
Let me check here because yeah, so something is missing here. So yeah, so for the first -1/3 x plus 5/3, and in the second case 1/3 plus 7/3. So something was incorrect here. Yeah, I added 3 coefficient to the linear addend. Yeah, so that's why such interesting result. So just a mistake. Yeah, so now everything is okay. And now let's see graph of the hyperbola. So this is the hyperbola graph. So here is it. By the way, yeah, also, so the center -1, 2, vertices, Fauci coordinates F1 and F2, then directrices, the first and the second, and asymptotes. So the first one and the second. And if I minimize, yeah, and move and yeah, and zoom in some so further, so we always can see that asymptotes, so the graph doesn't of the hyperbola doesn't touch asymptotes, but always moves to it. Any questions about this task? Okay, no questions. So we have one more curve, and of course, as you can guess, it is parabola. So because yeah, we need to play with all curves. So the analogical stuff doing. So 3x in power of 2 minus 6x plus 5, what we leave it here for now. So equals minus 2y. So moving y already here. So 3x in power of 2 minus 2x plus 5 equals, yeah, but equals minus 2y. Yeah, I won't move 5 for now. Then, so 3x in power of 2 minus 2x plus 1 minus 1 plus 5 equals minus 2y. So 3x minus 1 in power of 2, and here, so moving 5, so 5 minus 3 equals 2, so equals minus 2y minus 2. And what we have, so 3x minus 1 equals minus 2y plus 1. So that's what we have. So the canonical equation of the parabola. So parabola with the center in, so with the center with the following coordinates 1 and minus 1. Parameter p equals minus 1. No. I need to divide it by 3. So forgot to do it. So the center anyway remains without changes. So x minus 1 in power of 2 equals minus 2 over 3 y plus 1. So the parameter equals minus 1/3. So so let's find characteristics. So the focus has coordinates, so p by 2 plus 0, but it has coordinates. Yeah, don't forget that it looks like this, our parabola. So center in with coordinates 1 minus 1, so looks like this. So focus is somewhere here. So we add coordinates of the center, so 1 and p by 2, yeah, because x and y are swapped. P by 2 plus no, minus 1. So focus F has coordinates 1 and minus 4 by 3. So found it. Eccentricity is always 1. Of course, I will write it, but it doesn't make sense to do something with that. And directrix is the following. So y equals minus p by 2, yeah, because swapped, minus p by 2 plus y coordinate of the center. So the equation of directrix is the following. So y equals minus 1 over 6, so 1 over 6, and the center minus 1. So finally, y equals minus 5 by 6. So this is the directrix equation. And that's all that we found for the parabola. And let me share, yeah, I will share also this graph with you. By the way, does it open or not? This link. So you will be able to play
Yes.
with it. Okay. Yeah, maybe I will paste this link into these materials, but save it for some cases. And so graph of the parabola. So x minus 1 in power of 2 equals minus 2 by 3 by y plus 2. So the parabola, the center, no, not the center vertex. Yeah, it has no center. So focus, stop, minus, minus p by 2. Yeah, forgot to divide p by 2, so yeah, minus 7 by 6. My bad. And here is the directrix. Yeah, minus 5 by 6. Any questions about this lesson, previous lessons? No questions. Okay.
I have a question about individual work.
So send your individual work, or what do you mean?
Not about the task, but about the deadline for the second one. I can see it on the.
Let me check. I'm not sure. The deadline. Okay, I will ask the lecturer, and then I will let you know about it.
All right, thank you.
Okay. Any questions?
What about the test?
I also will ask when
Okay.
to open it for you as well, and we'll let you know. So maybe after the second group has this practical lesson, or maybe only for your group, so we'll ask about it.
Sorry, when is our last lesson from this module? Do you
This
know?
is the last lesson. So maybe it will be available for you today, or maybe when the second group has. So don't worry about it so much. So everything will be okay.
Okay, so
So more questions? Okay, no questions. And now we have some time, and I want to show you some usage of curves of the second order curves. So in current case ellipse in computer games, I guess you know something about Unity engine, and here is the usage of ellipse. So of ellipse. So as you can see, planets are moving by elliptic orbit. And how to make them move? We need to use the equation of the ellipse, but not our canonical form, the parametric form. Did you have such? So do you know it from the lectures or no? Parametric equation of the ellipse. Okay, if not, so that's just for your so some interesting information for you. Для вашого загального розвитку. So parametric equation of the ellipse is the following. So x equals a by cosine of t, y equals b by sine of t. T is the angle. Rotation angle. So with this, a and b are semi-axis. So with this angle, we always can know the rotation, position on of the ellipse. So t is from 0 to 2p. Of course, we can make it infinite, so any values, but nevertheless. So with the usage of this equation, I calculate point of the ellipse with using parametric equation. So I calculate x. So I multiply x is a by cosine of the angle, and I multiply y by so I multiply semi-x is b by the sine of the angle. And then so we have ellipse point with coordinates of x and y, and then each frame, so we calculate the position of the planet and it moves. By the way, it was my test task for the senior position of the Unity developer. So what I wanted to tell you, learn advanced calculus, learn mathematics. It will be useful in your future. Any questions?
No.
Okay, no questions. So have a nice day. Stay safe. And feel free to ask me some questions. Goodbye.
Thank you for the lesson. Goodbye.
Bye. Thank you for your attention.
thanks for the lesson and this interesting usage. Goodbye.
Goodbye.